This is a demonstration of total harmonics distortion measurement on the AFG31502. I've got the function generator itself. It's set up to 20 kHz, 1 volt peak to peak output as per the spec from Tektronix. And I've got the spectrum analyzer built into this Tektronix oscilloscope measuring the output. So I don't actually have all the recommended settings for this test, but I do have on center frequency span and bandwidth. They are all set as per the recommendation from Tektronix. I can't get reference level. The reference level is recommended for 8 dBm. I can only get 10 or 5 on this, so I'm stuck with that, but it shouldn't make too much of a difference. So the measurement is made up to the 7th harmonic from on the 20 kHz fundamental. So that's taking me up to 140 kHz. And you can see I'm having trouble picking up some of these peaks that are here. I can change this to averaging. It says, Tracy, that I can change this to averaging. And that gives me a little bit steadier. But even if I change these, the level down here, I'd be expecting this peak to be picked up, but it doesn't. So I've picked up 140 kHz now. So for those ones that are missing, I would just turn the cursors on and just shuffle them over to. So there, it's set up there. Those would be my readings there, and then dropping the 140 kHz now. I'm not sure why it's dropping that one off. I'll just move the cursor over to pick that one up. So what I'll do is actually pull up the spreadsheet that shows the calculation, and you'll see the recommendation from Tektronix, or the specification from Tektronix I should say, is 0.2%. I'm getting about 0.4%, and the culprit seems to be this second harmonic here at 40 kHz, which is about minus 44 dBm on this reading. Usually they're down around about the minus 60 to get down to 0.2%. So I'm not sure if it's something to do with this test setup, or there's some other issue at play here as to why I'm picking up almost double what Tektronix specify. So that's that test. I'll put up the spreadsheet results, and then we'll move on to the next test. So this is the actual total harmonic distortion test specified in the Tektronix manual. You can see here they show you the setup and the spectrum analyzer that they recommend. I don't have that one, so it's stuck to the MDO 34 for me. It tells you the settings here: 20 kHz, 1 volt peak to peak for the actual waveform generator, and then center frequency span and bandwidth for the spectrum analyzer, and the reference level to set it to as well. It then gives you a formula to calculate the harmonic distortion. That's the route I have to go down because my spectrum analyzer cannot perform the THD measurement itself. And it tells you here, it's back a little bit, so this section here, it tells you if all your harmonics are less than 62 dBm, then the calculation will automatically be under 0.2%. So it then goes on and produces this little table to go through the calculation methodology to eventually end up with the THD value, and it gives you the application of that calculation here down at the bottom. And if you want to see this being done using an oscilloscope and an FFT function, there's a video from a YouTube user, W2AEW. I'll put a link in the description, and he goes through actually using an oscilloscope and doing this calculation, and he explains it way better than I do. So I'd go and watch that video for a better explanation. The measurements made, I'll then feed this into a spreadsheet calculation. This is actually Mac numbers and not Excel, but it works pretty much the same way. Here's all the readings that I took for channel 1 along here, the DBC calculation, and then this CN calculation in order to add up and create the actual total harmonics value. And you can see both channels are around about the same, 0.37, 0.38 here for channel 2, so that's not meeting the 0.2 spec from Tektronix, and it is basically this second harmonic here that's been the problem. All the others are very close. I mean, 100 kilohertz, 59. That's not under the 62 specified, but that probably wouldn't make that much difference given the amplitude of all these others. And as you scroll down, you see I've done some measurements for some other instruments. This is a Regal DG1022, and it comes out around about the same, slightly higher. Unity UTG962. Again, similar sort of values. And the MDO itself, it's built-in waveform generator. That actually come out the best. That come out 0.33. So what I did then was actually go and did some extra calculations on the AFG31502, basically going through frequency band to see at what point I would pick up around about 0.2%. See here, at 1 megahertz I get a THD of 0.2091, so very close. And then at 1.5 megahertz you see it has dropped down to 0.1933, so somewhere between those two values is where it goes below the 0.2%. And you can see these remain relatively stable throughout. It's this second harmonic that's changing as you go down here. And then I've actually plotted this THD value, and you can see as the line draws through, this is my limit from Tektronix, and you see it crosses again between the 1 and 1.5, somewhere around about, if it's linear, which it looks fairly linear at that point there, you're somewhere around about 1.3, 1.35 megahertz.